This video will go through problems 21 through 25 of the 2009 released math OGT. You'll notice I also have the Desmos Scientific Calculator open. This is the calculator that you end up bringing up on the online version of the test. So any problems that we need to use a calculator on, we'll practice with this. So question 21, a grocery store has a triangular pyramid of soup cans on display. Stephen counts the number of cans in each of the top 5 layers. Each successive layer continues to follow the same pattern. The display has 10 layers. How many cans are in the 10th layer? So they give us 5 layers. We're going to have to keep going until we get up to the 10th layer. So we have to also figure out the pattern so we can figure out the number of cans for each layer that comes next. So from 1 to 3 cans, we either are going to end up adding or multiplying. Most patterns are based on addition or multiplication. So from 1 to 3, then we add 2 cans. From 3 to 6, we add 3 cans. From 6 to 10, we add 4. And from 10 to 15, we add 5. So when we go through this, usually our patterns end up matching up right there. We say, oh, we added 2 every time, or we multiplied by 3 every time. This time, our pattern doesn't match up. It's not the same number every time, but there's a pattern based on our pattern. We added 2 first, then 3, then 4, then 5. It's just counting up 1 each time. So if next we add 6, that's going to give us the number of cans for the 6th layer. So 15 plus 6 is 21. So next we add 7. The next number to add is 1 more than 6, and we add it to the number of cans on the 6th layer. 21 plus 7 is 28. Next we add 8. 28 plus 8 is 36. Next we add 9. 36 plus 9 is 45. And next we add 10, which is 55. So on the 10th layer, there are 55 cans. So when you look at your answers, notice they did include 45, which was one of our layers. It was the 9th layer, but they wanted the 10th, so we go with 55. Question 22. Local residents have requested a traffic light at the intersection of Polk Road and Vine Street. They claim that the intersection has become unsafe for their children due to the high volume of drivers using the roads as shortcuts during rush hour from 4 to 6 p.m. So there's some key piece of information that rush hour is from 4 to 6. In response, the street department installed a device that would count cars going through the intersection. The device counted the total number of cars each day for a 2-week period. The department used the results to determine the average number of cars passing through the intersection each day. So they did each day for a 2-week period, and it's the average number of cars each day. They decided the number was normal for an intersection with no light and refused the residents' request. In your answer document, explain how the residents can claim that the method the department used to collect the data does not provide valid information for evaluating their request. Explain how the department's method can be altered to provide more valid data. So the problem is the residents only were worried from a certain time period, 4 to 6, during rush hour when most of the traffic happens. So our sentence would say something like that. The residents wanted data from 4 p.m. to 6 p.m. only because of rush hour. The street department, they collected data for all day long. So in order to address the residents' request, so that's what was wrong, in order to address the request, they should only include data from 4 to 6 p.m. and calculate that. So a sentence like that, that is how you would answer that question of what went wrong. So we answered what went wrong, and we answered how can they fix it. Question 23. Points Q, R, and W are plotted on the coordinate grid. Where should point Z be plotted so that parallelogram QRWZ is formed? So a parallelogram is kind of like a tilted rectangle. Most of the time we see it kind of with the horizontal lines being the top and bottom of the parallelogram, but this time we would have it be kind of tilted itself. It was rotated. So this should look something like this. So what I do on a problem like this is I just try each point and see if it gives me the shape we're supposed to have. So -2, -6, if we try answer choice A, -2 in the x direction, you go from center to the -2 here, and then you count down 6. If we connected all of these, this is not a parallelogram. That looks closer to a trapezoid. So then we try -1, -3. -1 down to -3, and we connect the dots. And that does look a lot like a parallelogram. My lines got a little tilted because I couldn't draw them quite straight, so it's probably answer choice B. If you're unsure, if it looks maybe it's a parallelogram but maybe not, kind of circle B and say, okay, I'm going to come back to that. We'll try the other ones. +3, -2, that's way in the wrong direction. We wanted it close to this at least. And then 2, -1 for answer choice D is here. That's also way in the wrong direction. Just forms kind of a weird random shape. Maybe a kite. Looks pretty close to a kite, but I think it's off a little bit. So our answer choice B was the only one possible to get us the parallelogram itself. I was going to try and connect it one more time, but apparently I can't draw straight. Let's try this again. There we go. So answer choice B is our final answer. Question 24. A manufacturer wants to make a rectangular storage box with volume 0.75 cubic meters, length 1.5 meters, and width 0.4 meters. What is the height of the box? So when you have a box, also known mathematically as a rectangular prism, we have a length, a width, and a height of the box. We don't currently know the height. The volume is how much you could fit inside the box, and they gave us the volume is 0.75. So when you look at a rectangular pyramid, the volume is just multiplying the three sides together. The length times the width times the height. We do not know height, so we kind of have two possible ways to solve this. We could either try each answer choice and see if it gives us the correct volume, or we could plug in the volume, the length, and the width and solve that equation for the height. I think it's easier to use each answer choice. So length is always 1.5, width is always 0.4, but our height is going to keep changing as we try our different answers. So answer choice A is 0.15. We're going to multiply these together. 1.5 multiplied by 0.4 multiplied by 0.15 gives us 0.09. Not the volume we wanted. So answer choice A did not work. So now we try answer choice B. If you don't want to retype everything in, you can just erase and type in the new height, 0.45, and when they're all multiplied together, we get 0.27, also not our volume. We wanted 0.75 for the volume. So now we try C, 0.80. We type it in, we get 0.48, also not our answer choice, which means D has to be our answer. But you can always type it in just to be sure. So instead of our height being 0.8, now we do a height of 1.25, and we get 0.75 as our volume. So last one of this group of problems, problem 25. Kim is selling sandwiches for a school fundraiser. She made the chart below to help her with pricing. Which function represents the cost of the sandwiches? So if we want to find the cost of just one sandwich, we can take the total amount and divide by the number of sandwiches. We can take the $3.45 divided by 3. That's going to give us the cost of one individual sandwich. So typing it in, if you make a mistake, just hit the back button. 345 divided by 3. Notice when you hit divide, it makes it a fraction, but that's still dividing it for you. Gives you 1.15. So that is the cost of one sandwich, and now I bet you can see that one of our answers has this 1.15. Even though answer choice C also has the 1.15 in it, or answer choice D, since it's only sandwiches, we didn't have any other type of item, there's no drinks, nothing else, it's just the sandwich, then it's just the cost of each sandwich times however many sandwiches you buy. We don't need to add any initial cost because $3.45 was for 3 sandwiches, not like you have to pay $2 for a drink and then buy sandwiches. That's when you get this plus going on if you have additional types of items. So that concludes problems 21 through 25.